Hello boys and girls, good evening everyone. Yesterday we were exploring arithmetic progression and some of the problems in this, some of the n terms of AP as well as nth term of AP. Today we are going to explore the next concept of that, GP. Right, so let us see what are the topics that we are going to cover today. The very first one is GP definition and then general term or nth term of GP, and then some of the terms of GP, and we are going to take infinite GP also, and the last we are going to take 2-3 problems on HP and the definition of that. Okay na? So what exactly actually GP and how we are going to connect that to a real life events. Okay na? So let us take some real life examples, right? So you can see that if we are taking bacteria in a water box, so after 1 hour it is going to be doubled. Okay, and then next hour, so obviously it is going to be 4 times, and the next hour it is going to be 8 times. Now you can see that first hour if you are taking 2 times, second hour if you are taking 4 times, and third hour it is going to be 8 times. Like that it is increasing. You can see that, let us say there are 10 bacteria, next year it is going to be 20 bacteria you are going to have after 1 hour. There is an increment of 10 here. Similarly, if you are taking the next hour, it is going to be 20 times 2, that is going to be 40. Again here 80. So every term, if you are taking 10 here, 20 here, the ratio of these two numbers is 2 there. And if I am taking 20 and 40 here, the ratio of those two numbers also 2. And the ratio of these two numbers 40 and 80 also 2 here. So there is continuously there is a ratio here. So the growth of this bacteria is representing one progression. Let us define that later, but before that, let us see some more examples on the same pattern, how we are going to get that and in the real life, right? So next one is that bouncing ball. If you are going to take any football, if it is going to be dropped over there, then the height it is going to take after bouncing, okay na, it is going to be half of that, okay na, and the next bounce if you are taking, that is going to be again half of that. So it is decreasing half like that. First one if you are taking 1 meter, and the next one is going to be half meter, and the next bounce it is going to take 1/4 meter, right? So like that it is decreasing. There is a pattern like the ratio is going to be decreasing in this case, like half times of each the height, right? And the last one is sound intensity decay. For example, I am talking to you guys. Okay, now if you are in front of me, then the amplification or the sound wave, okay, now the sound intensity is going to be somewhat close. If you are closer, then it is going to be more. If you are somewhat away, like let's say 1 meter away from me, then there will be some intensity. If you are taking 2 meters away, then there will be a less intensity of the sound. So like that it is also dropping by taking some pattern there. You can see that sound intensity is going to be decreasing there, right? So there is a decrement here, there is a decrement of height here, but there is an increment of bacteria there. All these are following one property, right? Right, so that property here, that pattern is given by geometrical progression. So before defining, I am giving an example. Let us take 1,000 rupees is there deposited in 10% of rate of interest, but it is compounding. So in the first month if you take, or first year, it is going to be 1100 here because 10% is there. And then if you are taking the next 1 year, that is multiplied by 1.1 if you are multiplying, that is giving us 11 into 11 is going to be 121, and again if you are multiplying this one with 1.1, that is giving us 1331. So you can see that all these are in the same ratio here, this one to this and this one to this, this one to this. Thus ratio here is 1.1. That is called common ratio of the numbers that we are taking. And the same way we can define this progression, that is called geometric progression, a sequence where each term is formed by multiplying the previous term by a non-zero constant. That constant is called as common ratio. Usually we denote by R. Okay na? So you can see that rate of interest is increasing here, or rate of interest is same but it is compounding. The amount is increasing multiples of 1 by 1.1, right? So did you like these examples? If you like these examples, please give thumbs up here, because I have given the real-time examples how we are going to use GP for these examples. Right, next we are going to define, thank you very much Rajesh, Arjun, Prajwal, very nice. Now you understand how we are taking these real-time examples for the GP, and then we have general form of GP. Now you was given by that there is a term, let us take that term as first term A. After that, if you are writing multiplied that common ratio, as I told you, you are multiplying a number non-zero constant, I am taking R here, multiplying to A here, previous to that, that is giving us AR. So here R is called as common ratio, and then obviously we are multiplying AR by again R, that is giving us what? A times of R square. After that it is going like this, A times of R cube, like this. And if you are taking n terms, you can see that this is R power 0, R power 1 here, R power 1, R power 2, and the next one you can see R power 3. This is first term, second term, third term, and fourth term. When you are taking third term, it is 2. When you are taking fourth term, this is 3. And if you are taking fifth term, obviously it is going to be 4. The power is going to be 4. What if I am going to take nth term? Nth term, if you are taking A into R power n minus 1. One number is going to be dropped at the end over here. This one here is called as our nth term. Nth term of GP is given by A times R power n minus 1. I am just giving an example here. Let us take first term as 2. First term I am taking as 2 here. I am just multiplying 2 by 4 I am multiplying. 2 into 4 is giving us 8 here. So the ratio, common ratio 4 here. Again I am multiplying with 4, because that is our common ratio. Then it is going to be 8 times 4 is giving us 32. Like that you are taking, what would be our nth term? That is going to be to first term A you can see that is 2 here. And R I have taken already 4 here. So that will be 4 power, nth term will be 4 minus 1, n minus 1. So 2 times A into R is nothing but 4 there. And n terms, if you are taking nth term, will be 4 power n minus 1. What if I am going to ask you to find 10th term? 10th term will be equals to what? 2 into 4 power, that is common ratio. So here 10 is there, here n is, if I am taking nth term, then it will be n minus 1. 10th term if I am taking, that will be 9. Okay, now so that is how you are taking this GP here. So let us form that by taking this A and AR square, AR cube, like this. And nth term I have given already, I have given how we are getting that nth term, A into R power n minus 1. When you are taking A is first term, R is common ratio, right? And then I am giving one more example of this. By taking this one, I can give you nth term also for this one. You can see the bacteria of cell. Just before I was explaining the example of that, cell populations often double over the regular time interval. Previously, in the examples I was taking 1 hour. That regular time interval was there, that is 1 hour. If a colony doubles every hour, so that is exactly what I was giving there. So one bacteria will giving us 2 there. 2 is going to become 4, 4 into 4 becomes 8 and 16. So GP with common ratio 2. Now if I am going to ask you to write down this nth term here, nth term if I am going to take, that is going to be 2 power, so 1 into 2 power n minus 1. Okay, now after 10 hours, what will be my number of bacteria in that population in a given area? So what will be that? So 10th hour if we are writing, then it will be 2 power 10 minus 1, which is equals to 512. So there will be a population of 512 in a given area. That population will be increased like this. So that is following GP here. So that is how we are finding nth term of any GP, right? And then let us see some problems on this one here. So by using this general form of GP, how we are going to solve that? Every term of a GP is positive. We are taking all the positive numbers. Okay, and also every term is the sum of the 2 preceding terms. We don't know those two terms. That is why we are going to assume sum of the terms here. So as we were taking the general form, that we take A as first term, and then AR we are going to take it as second term, and we take AR square and obviously AR cube. Like this you are writing all the terms here. Now they were giving that sum of two preceding terms is equals to the every term. So this term I am taking AR square, one term is there. So these two are the preceding terms. What will be AR square is equals to in this case, that is A plus AR. Okay, now? So now you can see that A is getting cancelled on both sides of the equation, which is giving us R square, and I am taking R this side, that is giving us minus R minus 1 is equals to 0. I think everybody knows how to solve the quadratic equation. Please give me thumbs up if you are knowing already how to solve the quadratic equation by using the formula. I am giving general equation of the quadratic equation. Very good. It's like everybody knows this formula. Very nice, very nice. So I am taking the formula here, x is equals to minus b plus or minus square root of b square minus 4ac by 2a. Very nice. Now same way, in the place of x here we are having r. In the place of a we are having 1. In the place of b minus 1. In the place of c minus 1. I am just plugging all these values in this formula here. Then you are going to end up with the value of r is equals to minus of minus 1 is giving us 1 plus or minus square root of b square is minus 1 whole square, that is 1, minus of minus plus 4bc, 4ac if I am writing, that is giving us 4 divided by 2 into a is nothing but 1 only here. So this is the value of this r value. But what they are saying that every term of GP is positive. If I am going to take a is positive in this case, that r is equals to a is equals to 1, then r must be equals to what here? 1 plus square root of 5 divided by 2. Why we cannot take negative 1 minus root 5 by 2? Because if you are taking a positive or negative, doesn't matter. Let's say this is positive, then r if you are multiplying negative, this will become negative. What if I am taking this is negative, this will become positive. So but one term is positive, one term is negative you are getting if you are taking r is negative. That is not possible because they are saying that it is always positive. All the terms must be positive. That is why we are considering the ratio r is equals to 1 plus root 5 by 2. Right? Nice. Okay, so that is how we are solving by using this GP and finding what? The common ratio of the GP. And next let us see one more problem, that if m plus nth term is 4 they have given and m minus nth term also they have given 9, then we need to find mth term. Okay, na? So we don't know again that first term we don't know common ratio, but we can still find mth term because they have given this. Let us see how we are going to find. As we were taking that the variable a we are considering as first term and r is our common ratio, then give me what is m plus nth term. Can I write like this? M plus nth term is going to be a times r power m plus n minus 1, because nth term will be a into r power n minus 1. M plus nth term will be a into r power, here we are just taking minus 1. Similarly, why don't we take m minus nth term also, because they have given that one also. Term is given, this one they have given as what? 4 they have given, very nice. And this one they have given r power m minus n minus 1 is equals to 9. Okay, now to find mth term here we need to eliminate n over here, right? N, to eliminate n, why don't we multiply these two? So I am taking, this is first equation, this I am taking as second equation. We just multiply those two. Let us see what we get in this, right? So a into a square, r power, r base is common, same here r, then we can add the powers, which is going to be m plus n minus 1 plus m minus n minus 1. So here you are going to have m minus n and minus 1 is equals to 4 times 9 is giving us 36. Now you can see that this is a square r power, what we have here, 2m minus 2 is equals to 36. So can I take this one as, I am just writing here, that is a times r power m minus 1 whole square. So I am taking square here, power, whole power, and here 2 times m minus 1 I am writing as m minus 1 times 2. So I can write this one as a into r power m minus 1 whole square, which is equals to 36. Now square, if I am taking that side, we know already that is square root of 36, which is giving us a into r power m minus 1 is equals to 6. What is this term here representing? Isn't it mth term here? Yes, this is mth term. Mth term is equals to 6. That is how you are going to find when they have given different terms of this GP. Right? Are you liking this question here? Please give me the thumbs up. Yes, mth term can be also minus 6 here. So you can take that also, that is also correct. So depend on the options. If you are having that options, you are going to take it, because here square root is there, you can take plus or minus 6 here. Okay, na? So that can be 6 also. Right. It depends on the GP that they are giving. A and R fixed, not fixed. So depends on those values, we are going to take plus or minus 6. Right. Thank you very much. Right. So now let us connect this GP to the sides of triangle. We know triangle, if I am taking right angle triangle particularly, that it is going to have base and height here, hypotenuse. Now I am taking this one here as small capital A, B, C are the vertices of the triangle. Now in this base, if I am going to take greatest angle, they are asking cosine of that. Right angle triangle, they are in a GP. So all these sides are in GP. Let us take this is A here. This one over here is AR square. Why we are considering like this only? Why don't we take here AR and AR square here? Because hypotenuse of right angle triangle is always more than the other two sides here. That is why I am taking A is one side, AR is another side. Hypotenuse must be greater than of this, and here R is must be greater than 1 only. Now here AR square are right angle triangle sides, then we can simply write down A square plus AR whole square is equals to AR square whole square, because it is following Pythagorean theorem. So that is side square is equals to, is giving us what? Hypotenuse square. On simplification you can see that A square is getting cancelled. What we are left with? 1 plus R square is equals to R power 4. Again you are getting the same equation that previously we were writing. Okay, na? So the same way we were solving one equation, there instead of R we were having what? R square in this case. Now R square is equals to, you can write 1 plus root 5 by 4. We are not taking this 1 minus root 5 divided by 4 because it is negative value. Okay, na? Now R square, this value is there. What we need to find? Cosine of the angle, cosine of the angle. If I am taking smallest side, then definitely that is going to be A only. So this I am taking as theta here. This angle I am taking as theta. Okay, na? So this is our acute angle. This is the greatest one, because greatest acute angle is going to be opposite to the smallest side. This is smallest side here, smallest side. Then obviously this angle is going to be greatest there. Right. So in that case, what will be cos theta will be? Cos theta is equals to what we can write? Cosine of angle theta, cos theta is equals to, here greatest, this is small and this one here larger than, then your angle must be here alpha. Alpha is our greatest acute angle will be that, because these two if I am taking small side and large side. So this large side opposite angle is going to be our greatest acute angle, because these two are greatest acute angles, this one is greatest acute angle. So we are going to take, instead of cos theta, we take here cos alpha. Cos alpha is equals to, you are having this adjacent divided by hypotenuse, which is going to be, adjacent is giving us A there, divided by AR square, that is hypotenuse, which is equals to 1 by R square. What is 1 by R square here? One more small change here. This is not 4. We know that formula. That is 2 here. Okay, na? Right. So 1 by R square is equals to 2 divided by 1 plus root 5. So this is our cosine of the angle, largest angle in this triangle whose sides are what in GP, right? So this is how you are taking for triangle also we can apply the GP there. Now let's discuss about some of, okay, let us solve one more problem on this last one, this is last one. Now you can see there are 3 terms of GP and there are continuous terms also. But those 3 terms of not specified again. So to get the value of x here, I am going to simplify by taking the same way x comma 2x plus 2 comma 3x plus 3 are in GP. Okay, na? So I'll give one property on this. First, A comma B comma C, let us say, are in GP. Okay, so if I am taking common ratio, R is common ratio, this is A, and second term obviously it will be AR, and the third term obviously it is going to be AR square. Why don't we multiply A and C here? A times C is equals to A into AR square, which is equals to A into R whole square. So AR is equals to what we are having here? AR is nothing but B only, no? So that is B square. So we have got a property here. A comma B comma C are in GP, then definitely AC must be equals to what? B square. That is the property of GP, that is basic property. Now let us use the same thing over here. So this is A, this is C, here I am taking A, C, and this one here is B. So B square is equals to AC I am taking. What do we get? B square, if I am writing 2x plus 2 whole square is equals to what we are having here, A as x and C is nothing but 3x plus 3, right? So you can take here 2 common, that is giving us 4 times of x plus 1 whole square is equals to x into 3 common, that is giving us x plus 1. Now x plus 1 is common, what we are left with? 4 into x plus 1 is equals to 3 into x. Means x plus 1 also can be 0. X is equals to minus 1. Let us substitute x is equals to minus 1 in this. This is minus 1. This is going to be 0. This is going to be 0. Now is it forming 0 here? That is not possible, as we were taking the definition of the GP as what? Like non-zero constant we are multiplying. Right. So that is why we cannot take here x is equals to minus 1. Then we have left with, this is not possible here. Then we have left with this equation here. 4x minus 3x is giving us x. And if I am taking that side, it is going to be minus 4. So the value of x is minus 4. Minus 4 if I am taking, then you are going to get all these values here. Let us see that GP here. Minus 4 you are substituting. Minus 4 if you are going to substitute, what do we get here? Minus 4, and this one here is minus 8 plus 2, that is minus 6 there. And then minus 12 if you are writing there. Minus 12 plus 3 is giving us minus 9. So here you can see that the ratio, common ratio you are taking, the ratio of these two dividing, if I am going to write minus 4, minus 6 divided by minus 4 is giving us 3 by 2. Right. For the same thing here also you are going to get the same thing. So 3 by 2 you are multiplying for this one here. The fourth term here is A into R power 3, where A is equals to minus 4, R is nothing but 3 by 2 whole cube, which is giving us minus 4 into, this is 27 divided by 8. Now this is getting cancelled, we have left with minus 27 divided by 2. So that's how you are solving for x there, even though the terms of the GP are given in variable form also. Still we can get the value of x as well as any term of the GP. Right. So very nice. Sai, you have got very nice. 27 by 2 you are getting. Right. Nice. Sandhya, nice, minus 27 by 2, very good. Right, let us see that if 2 be our first term of and 4 be the nth term of GP, then we need to find the product here, P square, if P is the product of n terms there. So first term, if I am taking A is equals to 2 is there. So there is GP here with A is equals to 2, first term is 2, and 4 is our nth term. 4 if I am taking, 4 is equals to nth term A into R power n minus 1. Okay, now? Now, what they are asking us to find is product of all the terms. We have all the terms here. Product P is equals to A into AR into AR square up to how many terms we are taking? AR power n minus 1. So, how many times A is there here? It is going to be A. How many times are there? A into A, n times are there. So, that is why A power n. Similarly, R power 1 plus 2 plus up to you are having n minus 1. Yesterday, I have given an EAP, sum of first n natural numbers formula, that is n into n plus 1. But here what we are having? Only n minus 1 terms are there. That is why we take R power n minus 1 into n divided by 2. Okay, now you can check the formula of EAP, what I have given there, sum of the first n natural numbers there. Now you can see here, we need to find multiplication of these two, what we are going to get? A square into R power n minus 1 is giving us 8 there. Okay, now why don't we take here 2 is there, n minus 1 is there, n is there, n minus 1 is there. So why don't we take common here n, A power, then we are going to take here A square, and R power n minus 1 is there, whole power we can take n, and here 2 multiplied and divided by, that is giving us n by 2. Okay, now so I am just raising the power 1 by 2 and taking the square also for this one, which is equals to this one here as 8 power n by 2. What if I am going to take, this is P. Now what will be P square is equals to, that is going to be giving us what? 8 power n. If you are taking n terms of AP, GP are this, then you are going to get that. Let us say, instead of n here, if they are giving, there are 4 terms, then what do we get there? So which is equals to P square is equals to 8 power 4. Easily you can get that. That is giving us 2 power 12. Right? So that is how you are going to find out if nth term of GP is given, first term is given, then the product of all the terms also you can find out. Right? And then sum of GP we are going to discuss now. All these terms we are having from A to A into R power n minus 1. Why don't we add this? What we are going to get? Let us see that. Now the sum of the first n terms, let us see that by taking general form of GP, A plus AR square up to, I am going to write A into R power n minus 1. There are n terms here, this is square here, and I am going to consider this is an Sn. Okay, na? Sn again I am writing as Sn, but here R is there. What if I am going to multiply this all the terms by R? So this is going to give us AR. A into R we are writing like this. A into R, AR square you are going to get like this. Up to, before this term you are going to have A into R power n minus 2 into R, giving us what? N minus 1. Okay, now plus, what is this term will become? A into R power n. So I am just taking the difference of these two because all the terms are repeated here. We were multiplying R for the Sn here and just taking what? Difference of this. What will be the difference here? Sn is common, then here 1, here R, so that is giving us 1 minus R. Now is equals to, first term will be like this, but these two terms, all these terms are getting cancelled up to here. What we have left with at the end? That is giving us minus A into R power n. So Sn is equals to, A common on this, 1 minus R power n divided by, and here 1 minus R. You can write this one as R power n minus 1 divided by R minus 1. Okay, na? So this is how you are getting the sum of GP if you are taking n terms there. right? So n terms sum is this one here. Here r is not equals to 1. If r is equals to 1 there, this is going to be equal to 0. That is not possible. If you are taking r is equals to 1, that will give again AP also. You can take the sum there, okay, now by writing this constant GP. I'm going to give an example. For example, r is equals to 1 is there. First term is 2, second term is 2, third term is also 2. All these terms you can add. How many times are there? N times. So that is going to be 2 times n you are going to get. So if r is equals to 1, directly you can find using AP itself. No need to use this formula here because we are getting in the denominator r minus 1. Okay, so that is how we are getting the formula for n sum of n terms of GP, that is this here, okay, divided by 1 minus r. And then let us solve a problem on this. Okay, so how many of you know sigma notation? If you don't know, I am going to definitely give this. What is sigma notation here? What is that representing? Because in this question we have sigma here. Okay, so we are going to solve that by taking that. Please respond. How many of you know sigma notation? Right, right. Some of you don't know, I'm giving that. Okay, now simply I'm going to give with example. Let us say there is a sigma notation here and there is a function here f of I. Sigma means summation. I is equals to 1 to n you are writing. Okay, na? So these are the inputs here. They are always being integers. Now I is equals to 1 to n if I am writing. So you just have to write in the place of I as first one, 1. Plugging in 1 here in the place of I. Okay, na? That is f of 1 plus as sigma represents summation of all the terms. So I am taking next one here f of 2. Okay, na? Next obviously you are going to replace I by 3 and you write all these terms here and add. Okay, na? So this is our sigma notation. So whenever there is a function like this, you are going to write. I'll give an example for this. So let's say sigma is equals to I square is there. I is equals to 1 to 10 is there. Then you are going to write here 1 to 10 in the place of I. That is giving us 1 square plus 2 square plus 3 square plus up to like this 10 square. Okay, na? So this is how you are going to sigma. Right? Are you getting now? Please give me the thumbs up. Those who are not understanding sigma, now you are getting it. Right, right. Very nice, very nice. Okay, so I think you understand this, how we are taking this sigma. That you can see this. Thumbs up. Then what in the question they have given is nth term of GP is an. Okay, na? An is our nth term, or simply you can write an is equals to a into r power n minus 1. Okay, na? And positive numbers, all these are positive numbers. Let the sigma of the summation of all these terms up to a to n is 200 and a to n minus 1 is 50, such that alpha is not equals to beta here. So this is not there here. Okay, na? Then we need to find the common ratio. Common ratio we need to find there. For that one, I am going to take whatever the conditions they have given. What is the first condition? This one here I am writing a1, a2, n is equals to 1 we have to take the same way that we were taking here. And again a4 plus a6 up to a2n. Okay, na? Is equals to 200. And the same way. What is a2 is equals to? A2 is nothing but a into r, second term. What do you mean by a4? That is going to be a into r cube, that is fourth term. Similarly, a into r power 5 up to you are going to have a into r power. In the place of n, what we are having for the first one? N is nothing but 100 here. That is giving us a200. A200 means you are going to write 199 in the power of r, common ratio, which is equals to 200. Now let us see what is that second condition they have given here. Okay, so that is nothing but a1, because n is equals to you are substituting 1, that is giving us 2 minus 1 a1 plus next one you are taking a3, next one you are taking A5 up to you are writing A 100 if you are writing, that is 199, which is equals to they have given as 50. Now why don't we write all the terms here and check what we are going to get in this, right? So A1 is given as A, first term, A3 is nothing but A into R square, next A into R power 4, up to you are going to write A into R power 198 is equals to, that is giving us 50. Now you can see these two are similar, but only one extra thing is there, that is R in the first equation. Why don't we take R common in this? We get A R common, then we have left with A plus AR square plus AR power 4 up to A into R power 198, which is equals to 200, right? So I am writing the same equation. One thing I am doing is that I am taking R common. Okay, now R if I am taking common, you are going to end up with the same thing. So this entire expression you can see that this is equals to 50. Why don't we substitute in this here? So 50 is equals to 200. Any doubt in this part here? Please let me know in the comments if you have any doubt. I am going to explain this part again. Okay, that implies R is equals to 200 by 50 is giving us 4. So common ratio is going to be 4. Very nice. So you are getting this one now. You can see that R is equals to 4, you are getting the common ratio. Even though we don't know value of A and R, when they are giving the sum of these even terms and odd terms. Sanjana, please let me know what is wrong in this. Okay, so R you are getting as 4 here. Next, this is a sum. Now, there is a possibility that I was giving one of the example that one ball is bouncing, that height is decreasing. Eventually, it is going to go to the rest. Or else if you are going to take the decay of the sound, okay, na sound intensity, it is decaying. Then it is going to be eventually after some distance, after some distance it is going to be going to the 0. So sometimes it is going to reach to 0. So for that one the ratio must be between 0 to 1. I am going to show you with an example here. Let's take 2 here, okay na, as first term. So if I am taking R is equals to 1 by 2. What is the next term? It is going to be 1, and the next term we are going to be 1 by 2, 1 by 4, 1 by 8. So it's going like this, 1 by 2 power n minus 1 you are having. Okay na? You can see that it is decreasing, this value is decreasing, right? If it is decreasing there, all this sum is going to be converging to some value. So in this case it is going to be, you see, what is this Sn is equals to? Sn, if I am writing that formula, A into we have R power n minus 1 divided by R minus 1, where A is equals to 2, R value we have taken as 1 by 2, 1 by 2 power n minus 1 divided by 1 by 2 minus 1. We can simplify further, but what we are checking here is that n, if I am taking a finite number, this is fine, you are going to write the sum. What if I am taking, there are infinite numbers? You are going to take all these numbers infinite, okay na, way. So then in this infinity, n is tending to infinity, okay na, 1 by 2 power, let's say 20 is there. This is going to be 0.000001. Like that is going to be having more than 100 zeros after 0 here. Okay, so the same way, what if I am going to take 1 by 2 power 40? That is also 0.0000. There will be many zeros after decimal point. Then again, if you are taking more than this, n is tending to infinity, becoming larger and larger. You can see this is approaching to 0 and 0. So why don't we take here 1 by 2 power n is tending to 0 if n is tending to infinity. Okay na? So you can see that this is not exactly 0, but it is tending to 0. So 1 by 2 power n is tending to 0. Then n you are writing, n you are replacing with infinity. You can see that s infinity is equals to, you have left with 2 into this, we are taking 0 minus 1 divided by denominator is minus 1 by 2, which is giving us 4. So that means this entire expression or sum is converging to some value there. That is 4 in this case, right? So the sum we can take in this way whenever this value here r is 1 by 2. But sir, why we are taking 1 by 2? Why don't we take 2? What if we are taking infinite terms? Then also I am going to show you 2 we are taking. R is equals to, I am taking 2, that is going to be 4, 6, 8 and all these things. It is increasing here. Whatever you take the number there, that is increasing only. Your sum Sn is going to be 2 into 2 power n minus 1 divided by 2 minus 1. Let us take here n is equals to 20. 2 power 20 is very large number. That is why it is tending toward infinity. This is going to be infinity if n is also be infinity. That is not giving any finite value here. But here it is giving finite value. That is why we consider this one as infinite sum, or this GP is called as infinite GP. So let us see what is that infinite GP, how we are going to define. Okay, so infinite GP, we are taking common ratio. I was giving that R is always between what to what? Minus 1 to 1. So I am writing also, if n is tending to infinity, R power n is tending toward 0. This is very important. In the further classes, like in your JEE coaching, in the limits also this is going to appear. Very important, that one. Okay, now so we are going to consider R power n is tending toward 0, right? If R is between only these two, minus 1 to 1. I am going to give examples also in this. So S infinity, just now we have got the formula here. R power n is tending to 0. I have given Sn formula, that is A into 1 minus R power n divided by 1 minus R. So this is going to be S infinity will be, as I have given that R power n is tending to 0, this is going to be A by 1 minus R, because this value here is 0, right? So that is how we are taking. Now let us see some problems on this, how we are going to use infinite GP and these terms, right? Fourth term and first term. So first term they have given A is equals to 28. That is easy. Now what if I am taking fourth term? A into R power 3 is equals to 4 divided by 49. So you just have to plug in this. What do we get? R cube into 28 is equals to 4 divided by 49. Now R cube is equals to 4 cancelled with 7 here, that is giving us 1 by 49 can be written as 7 square. 7 square here, 7 times it is getting cancelled. 7 into 7 square is giving us 7 cube. What will be R is equals to then? 1 by 7. 1 by 7 is our, right, common ratio. Now what we need to find? Sum of infinite GP. Just now I have given the formula. S infinity is equals to first term divided by 1 minus that common ratio. R value we have, A value we have. We just have to write here S infinity is equals to 28 divided by 1 minus 1 by 7. So which is going to give us 28 into 7 divided by 6. On simplification, you would get here 2 times it is getting cancelled, 14 into 7 divided by 3. On simplification you can do that, right? So this is how you are getting the sum of infinite terms. This is always converges to some finite value if R is between minus 1 to 1 there and taking infinite terms there. I am going to give one more examples. I was telling you, that example bouncing balls, that let us take that one. So a football is dropped from 600 centimeters height and then each time it rebounds, okay, so it is going to be rebounds and it raises to 2 by thirds. 2 by thirds of the height it has fallen through. Now let us find all the distance that is travelled, all the bounces we are going to consider, and let us see how much it is going to be, whether it is going to be converges or not, right? So balls are bouncing like this. The height here h1 I am taking, h1 is given by how much in this case? That is given as h0. h0 is given by 600 centimeters there, right? And then first one here it is going to be 2 by thirds of that. So 2 by thirds if I am taking, so our R is going to be 2 by thirds. Okay, now this is like first term. Let us say A is equals to 600. Okay, 600 centimeters. Right, 600 centimeters, and R is given by 2/3 of the height because this total height is there. Again, it is going to give us 2 by thirds of height, right? Now, so next one here, again, it is going to be 2 by thirds of height here if I am taking, that is going to be A1 or A2 here, A3 or this is H1 there, and H2 if I am taking, that is going to be 2 by thirds of 2 by thirds into 600. So you can see that there is a ratio here for all the heights here of 600, right? So let us take all this ratio and A is equals to, we have got 600, and R we have got it as 2 by 3, which is lesser than 1. Then we just have to find S infinity. S infinity is equals to A divided by 1 minus 2 by 3. That is very simple. You can simplify that further. 3 minus 2 is giving us 3 into 6, 1800 centimeters. That entire ball is going to travel the distance. That entire distance is going to be 1800 centimeters. Please give me thumbs up if you like this question. I'm going to show you that. Okay, na? So that balls, if you are going to take all the gems, if you are going to consider, entire distance is going to be 1800 centimeters. Okay, na? The distance traveled by ball is going to be 1800 centimeters. Now, so I am taking about HP, that is going to take only 2 minutes. Right, so a sequence in harmonic progression, if AP, I am going to take A1, A2, A3 up to AN are in AP. Then the reciprocals of this, the reciprocals of all these terms, that is going to be 1 by A1, 1 by A2, 1 by A3 up to you are taking 1 by AN are going to be what in HP. That the reciprocal of the terms is called as what? HP, harmonic progression here. So if all these terms are in AP, then they are going to be HP. Let us see 1, 2, 3, 4 are in AP there. The reciprocals 1, 1 by 2, 1 by 3, 1 by 4 up to all these terms are going to be in harmonic progression. Now I am giving example here also. Here you can see the example. 1 by 2, 1 by 3 are in HP there because all these are in AP. Let us see the general form that A, A plus B, A plus 2D, all these are in AP. Yesterday we were discussing that. Then obviously the reciprocals 1 by A plus D, 1 by A plus 2D, 1 by A plus 3D. Now you just give me nth term of this. Nth term obviously will be equals to 1 divided by A plus n minus 1 times of D. So this is also in the reciprocal, if you are writing nth term of AP is giving us what? Nth term of HP there. And let us see one problem. After that we are going to wind up. This sum of the terms is given. Positive terms A, B, C are in HP. That means 1 by A, 1 by B, 1 by C are in obviously AP. So and then what they have given? The sum is given. A plus B plus C is equals to 19. And the sum of their reciprocals is given, that it is going to be reciprocals 1 by A plus 1 by B plus 1 by C is equals to 1 by 2. So why don't we write 1 by A are in AP, 1 by A I am taking as sum x plus D, x minus D, I am taking 1 by B as x here, 1 by C is equals to x plus D, where D is common ratio. So common difference in this case, right, because they are in AP. So adding all these things, what do we get? 1 by A plus 1 by B plus 1 by C is equals to, sum of this is giving us 3x. 3x is equals to what they have given? That is equals to sum 1 by 2. 1 by 2 I am writing here. 3x is equals to 1 by 2, x is equals to 1 by 6. What we need to find? We just have to find x over here, that is 1 by B is equals to, 1 by B is equals to x, which is equals to 1 by 6. So B is equals to what we are getting? 6. So B value they are asking us to find. Middle term B is equals 6. So no need of this one here. This one we can use to find D also, but we are not at all finding that one, right? So we just have to find. Sometimes they are going to give the conditions which are going to be distracted. We just have to find whatever that we require. So by taking these values you are going to write. So by all these 4 days we have discussed rational numbers, irrational numbers, AP, GP and HP also. Together I am giving a question for you to solve. You work on that. Okay now. Thank you very much for joining, and please like the session and share with your friends, subscribe to the channel, right, and comment on the comment box, right. Thank you very much for joining the session. This is your personal mentor Venkat Santosh from Chaitanya.